Hello, greetings. I am Patrick Morris, and this is my presentation on how big data is presented, stored, and retrieved from within Twitter's system architecture. A few topics that we will be discussing tonight will be Twitter's public API, Twitter's infrastructure, and Hadoop's distribution file system. Twitter, as we all know, has changed the big data industry. Before Twitter came along, most businesses relied on collecting data through surveys, blog entries, and etc. Now, thanks to Twitter, all of that is no longer the case. As we see live events unfolding in front of our eyes, millions of people's opinions are being posted on Twitter for the world to see. In the blink of an eye, you can already have an idea of what users think about any given topic. Thanks to Twitter, there is no shortage of big data. If you're someone who uses Twitter, then you're probably used to the standard functionality that comes with it. Of course, there's your feed. With that, you can see tweets and retweets by people that you follow. You can also see what is trending, of course, and what is trending for you personally. However, the odds are you're only seeing a very small fraction of what the Twitter app and mobile site have to offer. If you're an external developer, you need more than just Twitter's mobile site and Twitter's app to extract data truly efficiently. As we see here, Twitter provides us with some use case examples in which external developers could want data for. List and analyze helps users learn from the public when making decisions. Advertise, which helps with creating and managing Twitter ad campaigns. Publish and curate, which is Twitter helping tell stories with their content. And lastly, engage, which is using Twitter's API to develop applications that enable businesses to create human and chatbot conversational experiences. Twitter's API is how one goes about retrieving data. Twitter's first public API was launched in 2006. Version 1.1 was then released in 2012, with an emphasis on stricter policies that help to curb abuse and protect the Twitter platform. In version 1, Twitter allowed developers access to certain API endpoints without requiring their applications to be authenticated, essentially enabling them to access public information from the Twitter API without Twitter knowing who they were. Twitter notes that there were many applications that were pulling data from Twitter's API at very high rates, where all Twitter knew was the IP address of the applications. Fast forward to August 2020, and we have version 2. With version 2, there were 3 specific goals in mind. The first was abstraction. They wanted Twitter engineers building the Twitter API to focus on querying, mutating, or subscribing to only the data that external developers care about. Secondly was ownership. Their emphasis was on containing core and common API logic in a single place with a single team. Lastly, Twitter put an emphasis on consistency. They wanted to create a consistent experience for external developers by relying on their API design principles to reinforce uniformity. This brings us to the unified data access layer. Teams that worked on Twitter for the web, iOS, and Android went from individual internal REST endpoints to a unified GraphQL service. The team tasked with working on API version 2 did the same. This was because they noticed the needs of the public Twitter API were quite similar to those of desktop and mobile users. In case you were wondering what REST stands for, it stands for Representational State Transfer. REST is designed to take advantage of existing protocols. It works like a resource identifier to identify the particular resources that are involved in an interaction between components. Meanwhile, GraphQL's job is to execute queries by using a type system that users define for their data. So now that Twitter had their game plan on upgrading the public API, it was time to make it actually happen. This was broken down into 3 key components, the first being that Twitter needed a way for the different teams to build and contribute to the API. Their way they went about doing this was with routes, which were used to represent the external HTTP endpoints. Twitter also put a focus on selections, the purpose being to represent how to find resources. Lastly, there was an emphasis on resources themselves. They wanted to be able to represent the core resources in their system. To be put simply, the GraphQL service's job was to give more precise results from the endpoints. Okay, so you're probably wondering exactly what is being offered with the Twitter public API for users. What it provides is access to a variety of different resources, including the following: tweets, users, direct messages, lists, trends, media, and places. What V2 added was the ability to look up specific tweets, look up users, search for recent tweets, filter or sample real-time streaming of user tweets. Other new features included pull new metrics, annotations, new standardized JSON formats and functionality, and much more. Twitter offers memberships to its public API for developers. If you wanted a membership, the process would look a little bit like this. All you have to do is select the primary reason for using Twitter's public API and verify some account information. Once you're a developer with a membership to Twitter's public API, you go into it and punch in your endpoints, and let's say you want this specific tweet that we have right here. What you will get back with your endpoints will look something like this depending on what your request was. As you can see here, you get this long string of JSON back, and JSON stands for JavaScript Object Notation. To give a brief definition, it is a format for storing and sending data to one another. Obviously, this is a start, but not the most helpful of data, which brings us to the Hadoop distribution file system. Programs such as Apache Pig, Apache Hive are used to break the nested JSON down into a much more structured form for analysis. Once the JSON is in the FDFS, you can sift through the data a lot better and break it down into sentiment analysis. At this point, the data is finally able to be sifted through and easier to analyze. Tweets can be filtered by classifications of tweets such as positive, negative, impartial, among several other classifications. They can also be classified by topics such as sports, media, politics, etc. The tweets can also be classified by locations or even most commonly hashtags. There are ultimately plenty of ways to classify the data that can lead to interesting findings. For Twitter, their data center is currently 400% larger as of 2017 than they were when they first constructed it in 2010. Big Data Service takes up a whopping 40% of their storage. Twitter's Hadoop database has multiple clusters storing over 500 PB. These clusters are divided into 4 groups: real-time, processing, data warehouse, and cold storage. Twitter handles over 1 trillion messages per day. The messages are processed into over 500 categories and are selectively copied across their clusters. The architecture constantly requires attention as traffic for Twitter grows faster than they can re-architect an entire data center. They noted a few key takeaways, the first being how important it is to rely on data and metrics to make the correct technical design decisions. Secondly, they believed that there is no such thing as a temporary change or workaround. In regards to the client side of things, ViewFs is a large part in making life easier for many. ViewFs makes the interaction with Twitter's HDFS infrastructure as simple as a single namespace spanning all data centers and clusters. ViewFs removes the need to remember complicated URLs by using simple paths. Twitter scales HDFS by federating multiple namespaces. The reason for this is it allows Twitter to sustain a high HDFS object count in regards to index nodes and blocks without resorting to a single large Java heap size that would suffer from large garbage collection pauses. Twitter ViewFs is an extension Twitter uses with Hadoop. A Twitter blog, as shown here, gives a quick look into the construct process of Twitter ViewFs namespace. The blog summarizes this into 3 steps. If there is ViewFs mount point link, Twitter adds this right here. For consistency, they then duplicate all conventional links. This allows them to use the same notation regardless of whether they work with the default CD cluster or a remote cluster. Twitter can easily detect whether the configuration C-DC is a legacy Hadoop 1 cluster. For Hadoop 1, the keys, as shown here, point to HDFS URI, whereas Hadoop 2 points to ViewFS URI. Their Hadoop 1 clusters consist of single namespace / name node, so they can transparently substitute HFTP schemes for HDFS scheme, and simply add the link DC/C, and I will let you see the rest of this. Twitter ViewF's namespace is defined. However, at this stage, ViewF's link pointing to HDFS name services still can't be used by DFS clients yet. In order to make URIs resolvable, Twitter then merges relevant HDFS client configurations from all HDFS site.xml files and C-DC directories, and once that is complete, ViewFs can interact with Twitter HDFS. Lastly, Twitter data storage isn't something that is only found within their own data centers. As of 2018, Twitter has received some outside help with their data storage from a well-known source. Interestingly, the Google Cloud has taken on some of Twitter's cold data storage and flexible Hadoop clusters. Twitter believed this was necessary in order to keep scaling its business. They are planning on keeping the bulk of their infrastructure within their own data centers. They just believe this will help from a flexibility standpoint. Okay, all in all, that is my presentation on how Twitter presents, retrieves, and stores data. I hope you found this useful, and I thank you for your time.